So this is 413. So it says the building trades class at Kennett High School is planning to build an additional greenhouse using donated greenhouse panels. The class needs help determining how to best position the panels to maximize the floor area in the greenhouse. Only 3 sides need paneling because the 4th side is against the school. Do you see that there? So here's the school. They need a 3-sided greenhouse. And when the panels are positioned side by side, you've got 75 feet of paneling. And you can cut it up however you want. So we've got 75 feet of paneling. We don't know how to position the paneling. We can go out as far as we want. We want to maximize our square footage. So it says one idea is to have the side parallel to the school. So this side over here be 20 feet long. So I'm giving you a couple examples, and then we're going to figure out the best option. So if this is 20 feet, what would the length of X have to be on either side? How could I figure that out? How'd you get that? Yep, did people see how we did that? He took the 75, subtracted off 20. So he took 75 minus 20 and then divided by 2, and he got 27.5 feet. Right, so that makes this 27.5 feet right here. All right, so then it says, what would the area of the greenhouse be? How do you find the area of a rectangle? Length times width. So how did we do on square footage? 20 times 27.5, right? So 550, and that would be feet squared, right? So we want to see if we can do better than that. All right, so then it says another idea would be to have the side parallel to the school be 45 feet long. What will the length perpendicular be now? So if this is 45 over here, what does X have to be this time? So how would I figure that one out? So what did you do in your head or on the calculator? 75 minus 45 divided by 2, so that's 30 divided by 2 is 15 feet. Oops, that was this answer. And so now the new area is 45 times 15, right? 45 times 15. Did we do better or worse? We did better, actually, right? Because we had 550 before. So 675. I did that right, right? Okay, so now it says, let's fill in the table below. And so you've already done 20 and you've already done 45. So I'd like you to try to do 10 and 30. You see that down in the table? So we already did 20 as our parallel side. The length perpendicular was 27.5, and the total was 550. And then we did 45, and that made the other side 15 and 675. So I'd like you to try to do 10 and 30 the same way, and then we're going to come up with a function to figure out what the actual maximum is. 5. So we did okay here. So I wonder if one of those is the actual maximum or if there's actually a better option. So on the back page, it's asking us to think about, all right, what if the side parallel is just X this time? So I want you to think about, what do we actually do? We take 10, right? If that was X, we take 75 and subtracted 10 and divided by 2, and that gave us our perpendicular side. And then how did we find the area? We took the perpendicular side and multiplied it by 10, right? Which would be X. So let's think about how we would make an equation to do this. And then we could scroll in our table on our calculator. So write a function that represents area as a function of X. So it says you'll need an expression for finding the length of the perpendicular side, right? We said that was 75 minus X divided by 2, right? That gives us the side of the perpendicular, and then that gets multiplied by X to figure out the area. So area is 75 minus x divided by 2 times x at the end. So we could either leave it ugly like this, or we could try to make it, put it in standard form. If it's in standard form, how do you find the maximum value? Remember how to find the vertex of a quadratic? Negative b over 2a. So how could I put this in standard form? First, I would have to take 75 divided by 2, and then I'd have to take negative x and divide by 2. So that would be 37.5 minus 1/2 x, right? And we're multiplying that by x. So that wasn't too bad. So 37.5 minus 1/2 x times x. I'm going to put it in standard form over here because I can just switch the order. So I'd have negative 1/2 x squared plus 37.5 x. So did you see how I distributed the x to both terms? And I put it in the order that I wanted it. I put my x squared term first, and I put my x term second. So you could either put this into a calculator and follow in the table to see where you maximize, or you could do negative b over 2a. So see if you can figure out what are the actual dimensions. So what does x come out to be when you do negative b over 2a? And then you'd have to find the perpendicular side and then find the maximum area. So I think if I give you a couple minutes, you should be able to figure that out, right? This is b, this is a. You're doing negative b over 2a to figure out what x would have to be. Is there? And I think I forgot to hit unpause. So here was kind of my finishing calculations and my final conclusion.